Lesson 12, Submarines and Mapping the Deep. During the Cold War, there was a lot of Navy posturing with submarines, and all this nuclear submarine activity required accurate maps of the ocean floor, because you don't want expensive submarines with people in them crashing into things underwater. You need to know where the valleys and ridges are. To do this, they made ocean floor profiles with survey ships. One of the pioneering ships in that field was the German ship Meteor. And this vessel really broke ground on how you measure an ocean floor profile. And the basic of it is that there'd be a microphone on the bottom of the ship, and they'd send out a ping, just a loud noise, and it would travel through the water, down to the ocean floor, bounce back up to the ship where it would be received by the microphone on board. And you'd time how long these pings take to return. And so you'd take a ship, you'd go along, and it would go ping, it would hit the ocean floor, and you'd time that. Go a little further, ping again, hit the ocean floor, return. The ship advances, ping, hits the ocean floor, and returns. So obviously, the ping takes less time to return from this shallow point than it does from this deep point. And so when one of these surveying ships travels in a straight line across, you can make a sort of cross-section or a profile of how deep the ocean is at that point. So the result of some of these surveys was very interesting indeed. What they found was that the oceans are not just smooth bathtubs full of water. There's some interesting stuff down there, and the most interesting is in the middle of oceans. And in the middle of the Atlantic Ocean, there's a mountain range. And it's not just some small little mountain range. This is a world-scale feature, 60,000 kilometers long and extremely high. This is a pervasive feature on Earth's surface. And it was formerly unknown. So this was a big discovery. What's more interesting even than this fact is that in the center of the mountain range is a cleft, a sort of little ridge or valley in the middle, and it runs the entire length. It seems like this could be a feature of where a seafloor might spread apart. I mean, there's no proof of that, but if the seafloor was to spread apart and push the continents away from each other, this seems like where it would be occurring. Continental drift was finding its legs again at this point. We just didn't quite understand how.